So until now, what we discussed was SLA 3D printing. Now let's come to something that is a very, very new regime. And this is something that we have to some extent worked in also. This field is known as bio 3D printing. Bio 3D printing में होता क्या है कि the whole idea behind bio 3D printing is, you're basically using cell or protein or some biofluids such as stem cell, to develop a component which can be further implanted inside your body. So it can be anything, it can be bone marrow fluid, it can be protein, it can be tissue culture from your own body, which can be further grown into the laboratory, and it can be used to plant it inside you again to fill that defect that is inside you. All right. So what happens is, the idea is pretty straightforward. You have a syringe to deposit this material, this bioinks, and to make this component. So with the help of bioprinting, humans will be able to print living cells. Generally, this tissue, there are biogels with enriched proteins and vitamins. The biogel is kept in nozzle of syringe. After printing layer, there is need of curing with help of UV light. Just like photopolymers also, you can also train this kind of bioinks to cure with the help of UV curing. But there are also other ways to tackle the solidification issues. Like you can do it suspended in biogels. I'll come to it later. So let me give you a little bit introduction about this guy standing over here on the right hand side. In 2016, he was a TED Talk speaker, Dr. Anthony Atala, who is holding actually a 3D printed kidney in his hand. As you can see over here, this is actually a 3D printed kidney, which was printed by Professor Dr. Anthony Atala at his laboratory. And using this, he was actually able to make a functional kidney. Now, just to let you know, the functionality of this kidney is only 45% or 50% something. It has still not achieved the 100% functionality yet. But this research is still going on. And there are other examples where they are also printing, the cartilage of ears and, bone. So when you talk about bio 3D printing, the idea is not just limited to cells and proteins. It is also, you can also think about scaffold 3D printing. So scaffold is nothing but आपके body में कोई भी एक missing section है, जैसे आपका vertebrate का एक bone शायद टूट जाता है and you want to replace it with a metal 3D printed bone. Or a skull cap, some people might have accident and the skull cracks opens and it requires to be surgically fixed. You can always go for building a scaffold material, and the scaffold will be something like a replacement for the actual natural part. Now, the scaffold can be biodegradable. Sometimes it cannot be biodegradable. It depends on what type of material you are using and what 3D printing process you are using. Bone 3D printing, yes. So this is one of the example of scaffold where, I'll show you it is carried out in a Northwestern University where they are actually able to make 3D printed bone structure. So as you can see, this is actually flexible material. When a large area of bone needs to be replaced, the body can't handle it by its own. So, sometimes the synthetic material that are available, they are not up to the strength that is required. It often fails inside your body, and there is always a chance of material rejection. So the idea is, they combine a material known as hydroxyapatite with polycaprolactone, and they make a slurry kind of a mixture, and then they extrude it through a syringe extruders at a little bit elevated temperature of maybe 60 to 70 degrees Celsius. And they make a layer of structure they want. They can make any complex structure. So you can actually 3D print something. On the other hand, it's also flexible. That's the beauty of this material. So over the period of time, what happens is when you actually graft this bone structure that you have grown 3D printed to your actual bone, everything will fit in. Over the period of time, polylactocaptone जो है वो biodegrade हो जाता है, और hydroxyapatite is similar to your bone structure. So it will naturally convert to bone structure, and you have like a natural bone growth in this way. That is the whole idea behind it. So they have actually done animal trials on monkey where they have replaced a vertebrate of a monkey. That is what the research, I have gone through the research, and this is what they have been doing. So they are still far away from the human trials, but the idea is pretty straightforward, that you can 3D print a bone. That is the beauty of this technology. So prosthetic hands are also some of the very interesting point to talk about. You know, people with amputated hands, amputated legs, they can actually, you know, take advantage of this technology where, you can actually 3D print hands with a lot of servo motors on the inside, which will control their hands using your nerve sensors. So there are very sensitive nerve sensors available in the market, which you can embed inside this 3D printed hand, and it will actually function like an actual hand. That is the whole idea. There are people also there who are actually trying to put very small sensors at your tip of the finger. So when they put the sensor at the tip of the finger, they can also give you a pulmonary response that will tell your mind that, you know what, you are touching something hot, you are touching something soft, you are touching something hard. That is how you can actually get an idea, you can get the feel of an actual hand. These are some of the research that are going on, and people are working in this field. Next is something of a small example that we have worked on, and we have supplied it to one of our customers from the medical field. So the customer actually wanted to make a osteoplug. So let me give you a brief understanding of what an osteoplug is. You know, when there is actually, there are neurosurgeries happening, you need to make a burr on your head. The video, just a minute. So neurosurgical burrs, holes, and other cranial defects. That is what it is meant to plug. So let's say अगर आपको कोई skull injury है या फिर कोई tumor है that you want to operate, usually what the doctors do is they make a small burr on the forehead. They make this hole, and after that, once they make this hole, they actually operate the tumor or something similar to this kind of a process. We don't know exactly how, because we are not working in that field. But the idea is to fill this hole using this, bio plug. So as you can see, it is dipped inside our tissue culture blood sample, and then it is plugged over here. So होता क्या है कि जैसे ही वो plug वहाँ पे लगाते हैं, वहाँ से एक fiber का growth चालू हो जाता है, which will eventually fill up the voids and the porosities present. And over the period of time, since it is made of polycaproelectron, this polycaproelectron biodegrade होकर वो body से निकल जाता है, और वहाँ पे एक natural bone का structure eventually grow हो जाता है. That is the whole idea behind putting this plug. So these are actually some of the samples that we have made. And you can see the layering beauty of this printer that we have developed. It is so wonderful that you can clearly see the equal spacings from this holes, and that is the whole idea. So because of the capillary effect, the blood will stay inside the small porosities and holes, and it will actually make the full complete वो बनाएगा structure बनाएगा. Just a minute, I'll show you. So as you can see, repair of damaged blood vessels, that is possible, and then revascularization, angiogenesis, osteoblast activity, migration and proliferation. So osteoblast is nothing but a good transfer of the bone material onto this polymer, so that it can eventually convert the material into a bone-like structure. So regeneration of the bone tissue. And eventually, gradually in 24 months, it leaves no foreign material behind. And that's the beauty of this technology. So this is the printer that we had developed and delivered to our client. So as you can see in this picture, this is one of the flat mesh being printed on our printer. And it's a very specialized printer that was made using a direct drive extruder. It required a lot of tweaking and adjustment and a lot of trials. It took us almost 6 months to develop this printer. Some of the other fields that 3D printing holds a huge potential is custom orthopedic implants. So people who are currently in the orthopedic industry, they are trying to explore it, but there are still a lot of shortfalls of this technology. As I said before, that the fatigue life in metal 3D printing is not as good as the forged products and the casting products. So the whole idea is to take advantage of 3D printing where the strength plays an important role, but more than the strength, there is another advantage that we are talking about, such as developing a very specialized texture. So as you can see, this is in a femoral stamps. There is a ball and cup kind of attachment which gets attached to your pelvis bone, and in order to have a very good attachment with your pelvis bone, this cup is actually having a very specialized structure which cannot be made using the traditional manufacturing technique. So the best way is actually to have it metal 3D printed with such it's usually made of titanium grade 5, and it is having a very specialized texture which helps in osteoadhesion to your bone structure. Another very good example is the skull caps of damaged patients, and pelvis broken pelvis structure which can be repaired with the help of additive manufacturing. So these are some of the custom orthopedic implants that people are looking into. There are also people who are working in the field of making orthopedic implants for vertebrates. So for the 2 vertebrate sections that are actually being 3D printed. I think I have put up a photo also on the front in the bio 3D printing. Yeah. So as you can see over here, this is the one of the attachment between 2 vertebrae. This is another example of metal 3D printing custom implant, which we call, because everybody would not have the same vertebrate size. Patient to patient, it might vary a little bit. So another thing, that people are also trying to work on is something that we call biomimicking. So biomimicking is nothing but taking an inspiration from the nature to make something that is really very beautiful in terms of functioning. So in here, at I think ETH Zurich, Ecolab Polytechnic Zurich, they managed to make silicon valves that are similar to our heart valves. And as you can see the functionality over here, I'll just let the video play. So first they scan the patient aorta, and then they 3D print it on a very specialized machine. So this is a valve that is designed, inspired by the natural valve, and this is how it functions. It functions so beautifully, just like our natural heart functions. So as you can see. So this is something called biomimicking. There are also certain other examples where they are actually trying to make starfish-like structures that can hold objects. That is the whole idea behind that. Soft robotic arms. Then there is 3D printing in gel metrics. So another thing about bio 3D printing is taking advantage of gel metrics. The whole idea behind gel metrics is, you can have this gel infused with various vitamins and proteins, or you can adjust the pH, you can adjust the fluid type in such a way that when you actually grow this component inside, it gets the same environment as it gets inside your body. So that is the whole idea behind it. You can stimulating the environment to make the organ develop function like natural organ. You can make multi-layers and overhanging layers can be easily developed without the need for internal support structure. Generally ये बहुत ही बड़ा limitation रहता है FDM और SLA printers में, that if you want to make a component with an overhang, let's say आपका एक straight path है और फिर आपका एक overhang component है, तो होता क्या है कि आपको overhang के नीचे एक support structure भी बनाना पड़ता है. In suspended 3D printing, gel suspended 3D printing, you don't need to make this kind of support. Instead, वो gel itself will act as a support material and वो overhang वहाँ पर बनेगा. आपको कोई फिक्र करने की जरूरत नहीं है, वो गिर नहीं जाएगा. So this is the most helpful part when we talk about bio 3D printing, because there are so much of complex nerve structures inside an organ. When 3D printing this organ, when it is 3D printed in a biogel, it actually helps to a very significant extent. So let's talk a little bit about the challenges and the advantages in bio 3D printing. Acceptance of foreign 3D printed structure by human body is one of the very big challenge. कई बार ऐसा होता है कि अगर आप कोई organ बनाएंगे तो होगा क्या कि वो body आप let's talk an example of dialysis. कई बार लोगों को kidney donation चाहिए होता है, and when they get the kidney and they actually plant it inside the body, after a certain amount of time the body itself starts to reject that kidney. This is something of a very, very big challenge. And even for 3D printed components made out of polymers or metals, yes, it is very natural and very obvious for such kind of problems to arise sometimes. So the beauty of bio 3D printing sometimes comes into place when you actually talk about this technology. You are using your own bone marrow and making this ink, or you are using your own body tissues to make an ink, and then you're putting it back into your body again. So since it is made from your own bone marrow material or body tissues, the chances of that particular organ being rejected by your body is significantly low. That is something very, very important. Next thing is to provide the same human body environment for an organ or scaffold. So as I said, in gel suspension, yes, you can do that. That is something of a very, very beautiful part about 3D printing bio components inside a gel. Achieving 100% better functionality of the lab-grown organs or scaffold compared to natural organ. You need to achieve that 100% functionality. That is also equally important. And another biggest challenge that we face today in bio 3D printing is able to achieve the near net dimensional accuracy. People ask for you to print everything in XY accuracy of 20 microns or 50 microns, which to a certain extent, yes, it is possible, but it comes with a huge price tag. There are a lot of challenges.